Hello, this is Neapolis. Please, let's take our pen, our notes, and our calculator whilst watching. Whilst we are watching, let's jot something down. Don't just watch. This is not a movie. So let's start. Our topic for today, indices and logarithms under core mathematics. These are our objectives for today. Indices and logarithms. You start with indices, okay? You start with indices, then you go and deal with logarithm. In mathematics, indices is being applied in many fields, okay, under the computer science, engineering, and co. Good. If we have a larger number, we can put this larger number into a short form, that's into the index form. So they define the indices. Index form is a simple way of writing numbers. So the simple way of writing numbers is index form. That's the indices. Good. So you have 1,900 and something. We can put this one into the index form. Good. S to the power n is commonly defined as s multiplied by itself n times. There are n factor, but only n minus 1 multiplication. So I have this diagram. The law of indices, this diagram. We have 2. 2 is the base, and the 4 is the power or exponent or the index. Okay, so we can say that 2 to the power of 4 or 2 to the exponent of 4, okay, 2 to the index of 4, and so on. Now, example under this indices, we are saying that Sn is commonly defined as s multiplied by itself n times, and there are n factor. That is, 2 is a factor. So 2 here is the factor. 2 is a factor. 4 times, but only 3 multiplication. That's why I have this here. So 2 is the factor. 4 times, but only 3 multiplication. That's why we have n minus 1. So that's the definition for now let's move on to the law of indices. We are going to deduce the law of indices, how this law being developed. Law 1, that's the product law. The product law, I have this 2 times itself 5 times, okay? So 2 times 2 times 2 times 2 times 2. Good. So I have the product law, and product means what? Multiplication. Good. So this one, 2 times 2 times 2 times. If I want to put this one into the index form, I'll just 2 is the factor, okay? So 2 to the power, let's count 1, 2, 3, 4, 5. So 2 to the power 5, okay? 2 to the power 5. Now, I can also rewrite this as 2 to the power 3. 1, 2, 3. Then times 1, 2, 2 to the power 2. Yes, 2 to the power 3 times 2 to the power 2. Good. Since the base are the same for the multiplication, since the base are the same, we just maintain the base, then we add the top. Okay. Therefore, you see the same thing. So from this idea, then we develop this formula. A to the power m times a to the power m is this. Under the product law, let's move to the quotient law. With the quotient law, I have this 3 times 3 times 3 times 3 times 3. Okay, so that's 5 at the top and 2 at the top. So 3 times itself 2 times, and 3 times itself 5 times. Okay, good. So this, if I'm using the division, this will cancel this 3 and this will go. So left with how many here? 3 times 3 times 3. That's 3 to the power 3. Good. I can also rewrite this as 3 times 3 times itself 5 times. So 3 to the power 5 divided by 3 to the power 2. Yes. Since it's division, we just maintain one of the base, then we subtract the powers. Unlike like here, multiplication, we just add the powers, and division, we just maintain. Let's see, we get the same thing. Yes, that's 3 to the power 3. Good. So from this idea, then we develop the quotient law as this, or we can rewrite this as this. Then law 3, that's the power law. The power law. So this one I'm going to do with the powers, okay? So I have this example here. 2 to the power 4, bracket closed, times the power 5, okay? So this means that it's 2, maintain the 2, then you multiply the powers. If multiply the powers, you have what? 20. So this means that maintain the 2, then multiply the powers, then you have what? 20. Then I have this example there. So with this, 2 to the power 4 times 3 to the power 2. Here the bases are not the same. 2 and 3, they are not the same. So we cannot go and use the product law, okay? They are different bases. They are different. 2 and 3 are not the same. So we cannot use the product law. But there's power outside. And this power 5 is being affected by this and this separately. So this 5 will multiply the power of what? 2 to the power 4. Then the same 5 will multiply this. So this is what I'm saying. So 5 times the 4 is 20. Then 5 times the 2 is 10. Then we have this. We cannot simplify this further since the bases are not the same. Good. So from this idea, the first one, this is where we got this idea from. And then the second one, the second example, this n was outside. So this n is being multiplied by the y, and this n is being multiplied by the s, since the bases are not the same. Since the bases are not the same. So these are the law of indices that we have to know under indices. So we have 3 laws. Let's move on to the properties of indices. Properties of indices. I'll start with property 1. Property 1, I have this 2 times 2 times 2 divided by 2 times 2 times. So this one I can even cancel the whole of this, then I'll get what? 1. Or 2 times 2 is 4 times 2 is 8. 2 times 2 is 4 times 2 is 8. So this one is 8 out of 8. And 8 divided by 8 is 1. Very good. Then I can rewrite this in the index form as 2 to the power 3 divided by 2 to the power 3. And we talk about the quotient law, okay, division. We said since the bases are the same, for the division, we just subtract the powers. So we are just applying the quotient law here. So this is what we did. Then we have 2 to the power 0, 2 to the power 0. So therefore, we can compare the first one, the second one. So this one is same as here. You have 2 to the power 0. So meaning that 2 to the power 0 is 1. Okay, when we compare this. So therefore, we are saying that 2 to the power 0 is 1. That's why there's a saying that any number to the power 0 is 1. So even 100 to the power 0 is 1. Is from this idea. So therefore, we can conclude that a to the power 0 is 1. Property 2. With property 2, we have this. And with this, I can use the quotient, I can use the product. So since it's multiplication, let's use the product. The base 2 are the same. So we just maintain the base, one of the base. Then we add the top. But remember, it's 3 plus minus 3, okay? So in our level, it can go to 3 minus 3 because here it's negative. So the power is 3 minus 3, okay? Good, it's 3 plus minus 3, but negative is there. So we have this 2 to the power 0, that's it. But we know that 2 to the power 0 is 1. Yeah, number with the power 0 is 1. So therefore, from this idea, we can say that it's 1. Since we have this, from this idea, we can say that this one is 1. So if this is 1, I'm going to make one of these the subject. So I'll start with this one, the subject. Okay, everyone know how to make the subject. We just divide both sides. So I'll just divide both sides by 2 to the power 3. Then I'll divide here by 2 to the power 3. So that this will cancel. Okay, so this is what I'm saying. So 2 to the power minus 3 is this. This is what we have. Good. Or I will divide both sides by this because now I want to make this down the subject. So I just divide both sides by 2 to the power negative 3. 2 to the power negative 3. So that this will cancel this. Then 2 to the power 3 is 1 out of 2 to the power negative 3. Are we good? Yeah, good. Okay, good. So this can be written as this, and this can be written as this from this idea. Good. So from here, we can conclude. And if you want to change this, here, this one is being the same as 2 minus 3. Okay. So minus 3. So this one will be 2 to the power 3. Because minus is what? Plus. You see, you have the same answer. So it's very easy. You have to understand all this. Very easy. Good. So therefore, we can conclude that a to the power negative n is 1 out of a to the power n. For this property, another property we can say is this. Okay, good. So this is our property 2. Then property 3, we have this. The property 3, 2 out of 3, all bracket close, the power 3 here. This power, it will affect the two of them. Okay, so to affect the two of them. So this is what I'm saying. Good. That's property 3. So therefore, you can conclude that anytime you have this, you can rewrite as this. This for the property. We have stored the properties. Let's continue with the remaining properties of indices. I have property 4, and this property 4 can be written as, because we have we talk about a property which was a to the power negative 2, and we said that this one can be written as 1 out of a square. Do you remember this property? Yes. Okay, that's this property. Okay, so with the same idea, we can rewrite this as this. Okay, as this. Good. Now 1 square is still 1. That's what I said, square there. Normally that's how I write it. Wow. And then 1 with the power any number is still 1. Okay, so 1 square, then can we write this one as this. Then this one is same as 1. Okay, so I can do the rewrite as this. Okay, and we know for this property, that's it. So just factor the square out, then you get this. Good. Then after simplifying, you will have this. Okay, let me do a little bit explanation here. So 1 divided by 2 on 3. And this one, under our basic algebra, we know that it will be on 3 on 2. And this one gives us as well 3 on 2. That's why we have this. Okay, very simple. Very simple. Good. Now, we have another example here. The same working. Now we know that this one, the answer is this. Good. So the answer is this. Then we can conclude that when we have this, it would be like this. Okay, so the A and B will just interchange. Okay, the reciprocal, the negative sign. So after simplify this, you see we have this. After simplify this, we have this. So therefore, we can conclude that since this is this, then this property also holds. This property also holds. I have another one here. A times B to the power -1. Here the negative one is being affected by the B only, not the A. So this one can be written as A times 1 out of B, because we talk about a property which is this. Okay, and this will give us A on B. Good. For this property, A on B. So that's it. That's why we have A on B. So we cannot say that this one is same as this unless there's a bracket here. Okay, there's a bracket here and what here. Then this negative one will affect both A and B. So this one is same as this. This is what I was talking about. Good. So therefore, this can be written as this. That's for the property 4. Now with our next property, that's the 5 property, the 5th property. I have 4 to the power 1 on 2. And this for the power 1 on 2 can be written as, we all know this, that's the square root of what? 4. The square root of 4. That's the square root of 4. Good. So that's why I'm saying that A to the power 1 on 2 the same as this. So 4.5. Then 8 to the power 1 on 3, and this would be the cube root of 3. Okay, so this was the square root of 4. This one the cube root of 3. So you can say that A to the power n is the nth root of what? A. The nth root of A. So the denominator here, and this one is the square. Some people normally bring the square here. The same thing. Okay, the same thing. Good. Just the same. What about this? 8 to the power 2 on 3. It can be written as what? So this one is the cube root, but this cube root is being multiplied by what? 2. So this can be written as this. This is how we write this. Okay. So the cube root of 8 all to the power 2. That's why we have this there. Very good. And the property. So now we are done with the properties. The rules of indices. So these are the rules of indices. So now we are going to combine the law of indices and the property. I'm just summarizing everything here. So we talk about this under the product law. Since the bases are the same, we just add them under the product law. Okay, it's multiplication. We add the powers. Then talk about the quotient law, that's the division. Okay, since the base 2 are the same, since the division, we just subtract the powers, or it can be written as this. Very simple. And the power law, we talk about this. If here we are saying that the power is being multiplied. Okay, good. And the same thing, you see that this power is being affected by both a to the power s and b to the power 1 because the base are not the same. Good. So we just multiply the powers. And then we have this. We are just revising ourselves. So we said any number with the power 0 is 1. That's the property. And talk about a to the power negative n. And we said that this can be written as 1 on a to the power n. Or a to the power n can also be written as 1 out of a to the power negative n. And we talk about this one too. We are saying that the n will be affected by the a and b. If you want to simplify this, very good. Then we have this, and this one we just saw some working on it. Then we conclude that is the reciprocal. So b out of a, all into bracket the power n. Then talk about this one to say that a times b minus 1 can be written as a on b. Then this one, the power is being affected by all of them. So this one is 1 on a times b. Then talk about the roots. That's what the n root of what? A. And we talk about a to the power m and n. And that one is the n root of what? Times m. So these are the rules under the indices which we're supposed to know. And these are just the basic things that you have to know. So please try to understand these rules so that things will be more easier for me and you. Subscribe to Sneer Police, my YouTube channel, for more videos. Before we start solving example under indices, let's simplify this using the calculator. Okay, so they ask you to simplify this. Don't just go straight and type this one straight. No. Okay, so you have to break this one down because you have to get a method. So you ask ourselves, which number to the power 4 will give us 16, so that we're able to cancel it, then we move on. So we don't know unless you use the calculator, or you can use your head to do that. So we have this. So it's shift. Okay, so shift, then we come here, that's the power, and that's the nth root. I want you the nth root, and the power was 4, then 16. Then you know the number, that is the power 4 will give us 16. It was 2. So mean that 2 to the power 4 will give us what? The 16. So therefore, we can do our cancellation here. Here. Then let's move on to the next one, 81. So we use shift, then the nth root, that's 4, and what? 81. And that one too will give us 3, meaning that 3 to the power 4 will give us 81. So therefore, we can break this one down. Then we get what? 3. The same applies here. Shift, then the nth root for 32. So here is 5. So the n is 5. The inside will be 32. The inside is 32. Okay, then it's 2. So 2 to the power 5 will give us 32. Therefore, we can simplify this and move on. Okay, so this is our answers under this. Very simple. So we are going to make use of the calculator a lot. So let's solve example under indices. Good. So you are still on the topic indices and logarithm examples. Now that we know the rules and the laws, we can apply them and solve it very easy. Let's arrange this nicely. 9 here, 9 here, 2 here, 2 here. So I can rewrite this as this. Very good. Then we talk about a law, the quotient law, right? Good. We have 2 and 2 here, 2 to the power 8 and 2 to the power 0. With the quotient law, we said that since division, we just subtract it. So we take the base, then we subtract. The same applies here. 9, then we subtract. So 2, Then we just subtract the powers. Here 2, 9 here, 9 here. So under the quotient law, we just subtract the powers. Very simple. Now 2 to the power 8 minus 0 is 8, which you already know. Then multiply by, then we have 9. So for simplification, this is our answer. But if they ask us to evaluate, then we just multiply to get the actual answer. Evaluate this. Good. So let me rearrange them very nice. Okay, so then I can apply the law. So still I will use the quotient law. There's 3 to the power 5 and 3 to the power 2. So I just maintain one of the 3, then subtract the powers. The same applies to the 5. Very good. So therefore our answer is this. Good. So we cannot do anything here since the base are not the same. If the base are the same, then we will apply the product law, but the base are not the same here. But it's for, they say we should evaluate. So we have to get the actual answer, 27 times this, then this is our answer. Good. But if it is for just simplify, we just leave the answer here. Another example here. Simplify. It says simplify this. Wow. Yeah. And I even teach you how to use the calculator for this simplification. Very good. So we have to break this one down. 16 to the power 3 on 4. So we ask ourselves, which number raised to the power 4 will give us 16? And I teach you how to use the calculator. So please use the calculator. Okay, so shift, then use the end roots. Good. The same applies to the 81. Just use the calculator. So which number? So now that we know how to use the calculator to simplify this, let's break it down. This is what we have. Good. So 2 to the power 4 is this. Then 3 to the power 4 is this. And 2 to the power 5 is 32. So therefore, we can cancel it. Yeah. We can do the cancellation here nicely. I'll talk about this. So we know how to use the calculator to do all these stuff. Just cancel it. So we have 2 to the power 3 times 3 over 2. This is what we have. So then we should simplify this. We have 2 here, 2 here, so we can still break it down because there's 2 here, 2 here. So this 2 to the power 3 divided by 2 using the quotient law. So as maintain the base, then we subtract the powers. So 2 to the power 3 minus 1 times 3, then we can break it down. And this is our answer for the simplification. Very interesting. So we are still on example under indices. So simplify this. 8 to the power 2s on 3. So here you have to get rid of the denominator. So we can use the end roots on our calculator. Yeah, I did show you example on that. The end root. So that's the key root of 8 will give us 2, meaning that 2 to the power 3 will give us 8. So that we get rid of what the denominator here. So this will cancel. Yes, this will cancel this. Good. So we have this. Then we can simplify further. 2 to the power 3 is 4. Then that is 4s. Good. Evaluate this. We should evaluate this, and this one of the properties we talk about this a fraction to the power negative refraction. Okay, good. And we said that this one can be interchanged as 8 on 27, then all to the power 2 and 3. This was a property we did talk about that one too. So from here we can simplify it as nicely. So another property also say that with this power here affects 8 and 27, and there's it. Yeah. So now, so we can take the nth root. So cube root of 8 is 2. Then cube root of, we say is cube root of 27. You get 3. Please make use of your calculator. Yeah. So this one will cancel. Then, and this will be our answer. Good. So that's the answer for this. The next one, simplify this. I hope you can try this. Yeah, you can try this. Try it for me. Okay, let's do it together. Good. So here we have 6 to the power half. Can we get a square root of 6? No, it will give us decimal, so we don't have any number like that. What about 96? So there's 4 here. 4th root of 96. No, I think we'll get decimal there. So let's deal with the 6 first. So here is 6. We cannot do anything about this one. The 96 to the 4th root, you get decimals here. So mean that you have to look for a number. So there's a 6 here. So 6 times 4 to give us 96 rather. 6 times 4 to give us 96. Okay, so divided by this one, 96 is 16. So therefore 6 times 16 is 96. So let's break it down. Good. If you break it down, we have this. Then 216. So 216 the power 1 of 4. So we have 1 of 4 here. So let's take the 4 root of 216. Okay, that one to give us a decimal. But we have 6 here, 6 here. So 6 the power 4 to give us this. So let's take the 6 root. Please use the n. So the 6 root of this. What will be the answer? Okay, so it's 3. So it means that 6 to the power 3 will give us 216. You see, so we should make how to break this down. Now things have become more easier for us to simplify this. Now from here, this one is already there. We talk about this one under one of the law. We said that the power here is being affected by this and this. Okay, good. So this one of the law, we talk about this. So the power is being affected by this, and since the base are not what the same, we talk about this law. Then the 16, we can break the 16 down. Let's say the 6 here. We can break the 16 down here. So there's 4 here. So the 4th root of 16. Yes. Now we'll not get that one. Okay. So there's 4 here. 4th of 16. I think I have 2. So 2 to the power 4. 2 times 2, 4. 2 times 4 times 2, 8. 8 times 2, 16. Good. So 2 to the power 4 will give us this. And so this one here. So now things are a bit easier now. I have 6 here, so I can use the product law. Okay, so I'll keep one of the base here. So 6 1 on 2 plus minus 1 on 4. So plus minus 1 on 4 is minus this. Okay, so 1 on 2 plus 1 on minus 1 on 4. So this one we get what? 1 on 4. Then this one will cancel the 2 to the power 4. We'll cancel this. That's why we have this and this. Very good. So here too, the bases are the same. So it's 6 to the power 1 on 4. This one is minus, they put out this is the quotient law. So since the division, we just subtract. So it will be minus 3 on 4. And that will be plus. Yeah. So we keep the base 1 on 4 minus 3 on 4. And that will be plus. And we have this. So if you add them, you have this. Okay, very good. Then we continue from here. And this is the same as 2 to the power negative 1 is as 1 on 2. 1 on 2. And if you simplify, you get 3 because 2 goes here 1, 2 goes here 3. And this is the answer for this simplification. It was very tough, but with the steps and the law and the rules, you were able to solve this very easy. Subscribe to Stan Police, my YouTube channel. Subscribe to Stan Police, my YouTube channel for more videos. Yes, and if you want one-on-one or online, one-on-one with me, you just go to the comment section. You can send me hi there under my YouTube channel, or I have a link. You just click on the link, it will send to my WhatsApp page. Then we can have one-on-one teaching or face-to-face. Very good. Mathematics is very easy, and this logarithm is very easy. Don't shake with logarithm and the mathematics. Bye bye.